Okay, welcome to how the Supabase Architecture enables Super DX. My name is Ant Wilson. I'm the co-founder and CTO at Supabase, originally from Liverpool, usually found in Singapore, and you can find me on Twitter at Ant Wilson. First, what is Supabase? So we brand ourselves as the open source Firebase alternative. And what that means is we're a database company. So we provide a hosted database platform, which you can deploy in under 2 minutes. But you can also, because it's open source, self-host everything that we have in the Supabase stack. If you've used Firebase before, you'll be aware that there is an authentication layer. So you can do your user management in Firebase and in Supabase as well. It's as simple as supabase.auth.signup and then pass the email and password. We have a file storage system, which is a little bit different to database storage in that you can store large blobs like files or videos. And coming soon is functions. So cloud functions, which if you've used Firebase, you should be very familiar with, is going to be a part of the Supa stack very soon. Now, the Supabase architecture, so I'll get a little bit technical now and talk about all of the components that make up the Supabase stack and what you get. And obviously the core is Postgres. So Postgres is an open source database. It's been around for a while, loved by developers everywhere. And so the first thing you get when you deploy on top of Supabase is you get a full dedicated Postgres instance, and it's hosted at db.myprojectref.supabase.co, and you can just connect to it directly if you want to. And then every user will have Kong. Kong is an API gateway, also an open source tool, and every user gets this URL, myproject.supabase.co. And then let's say you want to start communicating with your database over REST, over a RESTful API. If you want to do creates, reads, updates, deletes, then we auto generate this API for you. So you no longer need to write the API layer. You connect directly from the client and make all of your queries over this RESTful API. The tool is called Postgres. It's an existing open source tool, again, a little bit like Kong, that we've pulled into the Supabase stack. And so if you go to your URL /REST, then you can start communicating with your database. The next thing we have is the real-time engine, the real-time API server, which was written in-house at Supabase and, of course, is open source. It's written in a framework called Elixir, which is extremely horizontally scalable. And so you'll find that at this /realtime endpoint, you can subscribe to changes in your database over WebSockets. And you can subscribe on a table level, on a database level, on a column level. If you can do equality matches, and it's also secure, which I'll talk about when we talk about the auth endpoint as well. The next thing is an API called GoTrue. It's written in Go, which is why it's called GoTrue, and it's the tool that enables us to do user authentication and user authorization. So authentication is obviously logging in with your, let's say, your email and password. We also secure magic links. And you can do login with mobile over OTP, sending OTPs over SMS and things like that, which is all enabled using this tool called GoTrue, and is available on the /auth endpoint. And like I mentioned, we also have file storage, which is effectively a wrapper around S3, which will be on the /storage endpoint. The storage API was written again in-house at Supabase, and it just has a very developer-friendly API for uploading files, downloading files, listing everything in a bucket, searching for specific files. Very, very handy. And the last one is kind of an internal application. It's called PG Meta, and it's what we use when we connect to your Postgres instance via the Supabase dashboard to set some configs in your Postgres database and do some configs things. And so you don't really need to dig into that if you're not a very advanced user, for example. And so what we want to talk about is how this architecture, the way we have this modularization of all of these components, actually enables us to give a really good developer experience. And so when you think about a platform like Supabase, which provides a database as a service, it provides these APIs as a service, what are the DX or the developer experience touch points that are important? What do we think about? What are we improving upon? And there's four main ones. The primary one, which I'll talk mostly about today, is the client-side developer experience. So let's say you're writing a Next.js app. Let's say you're writing a mobile application in Flutter. What does that experience look like? Can you just pick up Supabase and start playing around and sending and receiving data? And is it easy? Is it easier than other solutions? The next one I'll talk about is deployment. So deploying on the Supabase platform, you obviously come to our web app in the browser and you can deploy your instances. I'll talk a little bit more about that. How do you administer your database? You shouldn't need, if you're a small operation, you shouldn't need a DBA anymore as one of your 10 members of your development team. We should be at a point now where you can manage that effectively. And what are the existing tools and how have we improved upon that at Supabase? And then the last one is local development. So let's say you don't want to develop on the cloud platform just yet. You want to just develop it locally. What does that experience look like? So the first one, client-side developer experience. Let's dig into that. So firstly, we provide Supabase JS. There's not only a JavaScript library, we also have a Python library, which was written by the community. There's C#, there's Kotlin, there's Flutter and Dart. There's a whole collection of these libraries. But they effectively all do the same thing and they have very similar functionality. So I'll talk specifically about the JavaScript and TypeScript library, but everything I say here applies to the other languages and frameworks as well. So Supabase JS is actually just a wrapper around four other modular JavaScript libraries. The first one is Postgres.js, and like I mentioned, this is what you'll find on the /REST endpoint when you have a Supabase database. And an example of what this looks like is Supabase.from cities. Cities is a table that exists in my Postgres database, and I want to do a select. And inside select, I can pass it some columns. I just want the name of the city, or I want everything. I'll give it the wildcard. I'll put a star in there. But this is the kind of thing, and you can get very complex on the filtering operations. So you can keep chaining filters onto the end for equality, and there's some very nice full text search tools which are also available in Postgres.js. The second thing that we wrap is GoToJS, which is on the /auth endpoint. And this is what that looks like. So supabase.auth.signin, pass the email and password. So it really is as simple as I made out earlier. to sign up your users, sign in your users, sign out, request magic links to be sent over email, this kind of thing. The third thing is real-time JS. So again, just we spent a lot of time iterating on these APIs. So you'll notice that it's quite close to SQL actually, because that's the biggest difference between Firebase and Supabase. Is Firebase is a NoSQL database, and Supabase is Postgres, which is very much a SQL database. It's relational, and we didn't want to abstract that too much. We wanted it to feel as much like you're querying a database as possible, which is why we have the from keyword and the select keyword. But then we obviously, for subscriptions, it made sense to say, well, on an insert or on a delete or on an update, receive the change and run this operation. So in this case, I have a method called foo, which I just want any new data that has been inserted to go to be passed to foo, and then we'll do something with it. And then .subscribe will initiate the subscription. So then I'm just listening over WebSockets, and if anything changes, I'll trigger these events. And the last thing, Supabase storage.js on /storage is again just kind of straightforward. .storage .from a given bucket. I want to download this file, and the file will be a string. Actually, it'll be a path. So it'll be folder /file.png or whatever. And a sneak peek, this is the first time we've even talked about this anywhere, actually, I think, is that we will probably have something called functions.js. Now, this isn't finalized, so the documentation might look a little bit different, but this is the kind of interface that we've started to play around with, which obviously is Supabase.functions, and then you invoke your cloud function and pass a bunch of parameters. Now, like I said, this isn't finalized, but it's a pretty, I'd say it's pretty close to where we'll end up. Now, the fun thing about Supabase is it's designed so that you can communicate with it directly from the client. So directly from the browser or the mobile app. And the first question a lot of people ask is, but how is that secure? Because you're always taught to never trust the client when you're building applications, because the user can effectively go into the JavaScript and execute whatever they want. And because of the modularization and the way these tools work together, we've come up with a really nice solution for making it secure. So let's say we have our friend Alice here. Alice is a space cat, and she wants to sign up for spacecats.com, the social network for cats in space. And the first thing she'll do from the client is she'll invoke supabase.auth.signup, and she'll pass her catty email and catty password to the site. And how this works behind the scenes is there is an auth.users table that lives inside your database. So this is the main difference between something like Auth0 and Supabase, is that in Auth0, this users table will exist in Auth0's own database. But with Supabase, this data lives inside your Postgres database, which you have access to. Now, the nice thing about that is when you start developing your own schema, you can join with these tables. You can make foreign key relations to the data that is in here, and you have ultimate control over this data, which is quite nice. And everyone will get a UUID, which is an important point. Then what we do is we send back what's called a JSON Web Token, a JWT. We have a deep dive series on JWTs in Supabase. Just Google that on YouTube if you want to really go deep and get a good understanding of how this flow works. But basically, it's effectively a JSON object with this what they call claims. So the key values are just referred to as claims. And there's a claim called sub, which is short for subject, and it's going to contain the UUID of our new user, Alice. And she gets this JWT and she keeps it in her browser. Then she wants to start interacting with the social network. Maybe she edits her profile and she wants to set her name and set some coordinates of where she is in space. Now what happens within Supabase JS is we take that JWT token and we now start attaching it to every request that comes from the client in the authorization header. You'll see it says here bearer. That's just because Alice is the bearer of this token, and she's gonna use it to consume some data or edit some data on spacecats.com. So she'll make this request, and the token gets passed back to the Supabase server. Now this is how we're able to secure the database itself. Is you will enable something called row level security for a given table. So RLS for short in Postgres. So if you just Google Postgres RLS, there's whole tutorials on these policies, and it's all in SQL. So I'll write a new policy on my public.cat table, which says create policy, and I give it a description, can insert cat on the table cats for insert. So only insert. I could list insert, update, delete, maybe, using this policy and using we have auth.uid is equal to sub. Now this just means that the first side on the left side of the equals sign is us plucking out the sub value from the JWT that was passed in. And what we're saying is the row that we're trying to insert, if that is equal to the UUID that we've passed in the request, then allow the user to set this value. Actually, I've made a mistake here. On the insert, I should have passed name, sub, and coordinates. I should have passed sub as well. Just missed that out. But and the same for if I want to read data, I would do create policy on cats for select using and probably the same filter there. And then, okay, we've been allowed to insert the new data into the table, into public.cats. And so we have a new row, which is Alice the cat. She's at in some crazy nebula somewhere. And she has this sub, this ABC123, which is her UUID. So that's how it's secure. And the same applies for the other API endpoints as well. So if she wants to interact with Supabase storage, we actually store all of the files in S3 on AWS. But you only obviously have permission to access files within your Supabase project. But you can write policies for given users to be able to write or update or delete according to the policy that you write. So a great example is profile picture. A user should be able to upload a new profile picture, and only that user can edit the profile picture. Now, the nice thing about this is we store all of the S3 metadata in your Postgres database. So you can write these policies against the object tree, basically. So you can say not only, oh, I want the user to be able to edit this specific file, but you can say, oh, anything within this specific folder or subtree of S3. And there's an example of a generic policy, which is create a policy description on my table for select or update or insert using, and then the logic you can put in here is basically whatever you want. It's Turing complete, so you can go as complex as you want. Just bear in mind that whenever you make a request to the database, this code will be run. So if it gets too complex and tries to do too many joins from other tables, then it could be create performance issues. But that's very unlikely. It's typical that the checks are just a simple check like this one. Okay, so that's the client libraries and a little bit about the developer experience there. And now we can move on to the second thing, which is deployments and how we think about deployments in DX at Supabase. So the main thing that we were inspired by actually is Firebase. Now the great thing about Firebase is you go onto the Firebase website, you click a few buttons, and they deploy a new Firebase instance for you into Google Cloud. You don't need to really do anything else. You might set a few config options, but it's really straightforward. And that's where we wanted to match the experience. It's just basically one click. Amazon RDS, if anyone's deployed on Amazon RDS, maybe Postgres, you might have an idea of the experience there. It's fairly long-winded. There's a lot of configuration and options out the box, so you do need a basic understanding of how databases work, maybe a little bit about networking in order to get going. But again, it's just you're going on to a platform with an interface and you click some buttons and you get the database. So yeah, still a fair amount of config. And the last thing we took inspiration from is self-hosting Postgres, because what you get when you self-host Postgres is you get full control, and developers love to have control. And maybe developers won't always capitalize on having that control, but it's more about the knowledge that if something goes wrong, I want to have the ability to go in to my database and fix it if I need to. And that's the thing we wanted to capture with Supabase as well, is you should feel that you are in control of your own database. It's your data, so you should have ultimate control over that experience. And I think that's where RDS, for example, falls a little bit short, in that it's quite restrictive in the type of extensions you can install, and some things like that. So you don't quite get the full control that you do with self-hosted. But the downside, obviously, is you really need to know about networking and security and how to secure a database if you self-host it yourself. And so at Supabase, this is how it works. You come onto the app.supabase.com, you click a button, you fill out a form, you choose the region which you want to deploy into. And we give you two things. We give you a dedicated Postgres cluster. Now, dedicated is the key word here because this is the part that gives you the control. And we give you all of the applications that we mentioned earlier, the auth server, the file storage server, the real-time server. So one-click deployments. Every Monday morning, I actually speed run how long it takes to deploy an instance on top of Supabase. We call it time to value or time to query. And what we're trying to do is minimize the time between when you land on the Supabase website and when you can start querying your database. And we've gotten that down to about 1:40. And we're putting a lot of work into making the deployments even faster, because the main chunk of time there is when we actually deploy the Postgres instance into the cloud, the time it takes to come up and be available for queries. And we've done a lot of work on streamlining the VMs, the AMIs for that, which will be deployed out soon. And we'll hopefully get that down to around 15 seconds, which which I think is probably one of the fastest Postgres deployments in the world. And scalability, you shouldn't have to worry as a user of Supabase about the horizontal scaling, whether your instance has access to enough resource. And so we have a lot of metrics tracking built into all the instances so that we know, oh, this particular user has reached 80 or 90% of their storage capacity. Let's automatically enlarge the size of the disk that they have access to by 50%. So a lot of this stuff is automated. Some of it is requires our manual intervention, but we're working on automating this out as well. But you shouldn't need to be concerned with whether you're using too much resource. We should be able to manage that for you. And we also don't want to hide that from the users. So if you go into the Supabase dashboard, you can actually see for CPU and for RAM and for disk IOPS, like how you're how hard are you pushing your database basically. And then control and extensibility, again, it's just Postgres. We give you the Postgres connection string. You can connect via your own command line and basically do like almost anything with it. It's also, the image that we use is also fully open source. So anyone can contribute to the extensions and plugins that we use in the Supabase version of Postgres, which is basically just vanilla Postgres with a bunch of convenient extensions pre-installed. So database administration. One thing we love about Firebase, again, is we love Firebase. Actually, it's great. If you have a NoSQL use case, you should definitely use Firebase. Like if you've got lots of unstructured data. And one of the cool things on the Firebase dashboard is they have this object tree which you can collapse and look at different nodes. And a great relational version of this we came across was Airtable. So if you look at Airtable here, you can actually create new tables, create relationships between those tables, create new columns and rows, all within the browser, and the experience is great. So we just wanted to emulate this experience, but put it on top of Postgres, because then you have a great experience of editing the data. Maybe it's just for while you're in development, you want to use this, but maybe you're giving it access to some backroom staff who should have the ability to use a front end to just quickly edit some data. So we took a lot of inspiration from that. And then also more advanced Postgres tools like pgadmin. pgadmin, famous desktop application for managing your Postgres database, really has just tons and tons of features for DBAs. A great query interface. Just an all-around great experience, but it's not available online as a service. You have to download it and run it on your own computer. And so this is what I would call our Airtable style interface, the table view we call it. If you go to GitHub and go /Supabase/grid, you'll find the React component which we developed here, and we're working towards this Airtable style experience where you can just come in and edit and click to add a new row, click to add a new column. You can explore foreign keys and really drill into the data like that. And we also have the SQL editor. So this is our alternative to pgadmin, if you will. Now on the right side here is actually a full Monaco editor. Monaco, again, like a great open source tool for for building coding interfaces like this. And the auto completion is like just class. So the cool thing about the auto completion in the SQL editor is it obviously has access to the whole SQL lexicon, but also has access to all of the table names and column names within your database, within your schema. So you can see here it's suggesting an autocomplete for my countries table. So yeah, really cool, really powerful. Maybe you won't use it if you're brand new to databases, to relational databases, but hopefully you dig into it and you learn about the SQL. And this is one thing we struggled with from the start was, okay, we definitely want to use Postgres, but Postgres can be as complex as you want it to be. And so how much of it do we abstract versus educate? Like we could, for example, the row level policies, we could create a visual editor that you click and drag. But abstractions are kind of weak when you do things like that because you don't get the full power. It's much better in that instance to just do a little bit of education, just have some great documentation, some great tutorial videos on how to use row level policies, how to write row level policies. And so the reason we are so focused on providing a great SQL editor experience is because we want people to learn about SQL. It really is like probably the best way to query your database. And every dev should have that in their arsenal. And the last thing now is the local development experience. So let's say you're not ready to deploy out to Supabase Cloud yet. Let's say you want to run it locally. Then what everyone should be aiming for with a local development experience is you should be able to run it on airplane mode. You should be able to turn the Wi-Fi off and still develop on top of Supabase on your local machine. It should have all the tools you need to develop locally. And then when you're ready to deploy out to the cloud, that's kind of the optimal local development experience. Kind of like an example of something that doesn't do that is like Stripe's APIs. You kind of have to be connected to the web, connected to the Stripe infrastructure with good reason. But you can't really like connect to their full stack when running locally. As far as I'm aware, they might have changed that. And this is a bunch of code, but this is basically how we run the applications locally is with Docker. So what you do is you install the Supabase CLI, which you'll see in the top right here, and then you can type Supabase start, and it'll just start running a full Supabase. All the architecture that you saw earlier, it'll have it fully connected up, and it'll just start running locally. And here's what the Docker YAML file looks like, just to show you that the services are just self-contained, but obviously interact with each other in the ways that I showed earlier. And you can kind of play around with this as much as you want. The other good thing about this is you can use it to self-host if you just prefer to self-host Supabase and rarely have 100% full control over every aspect of it. Then you can just take this and run it on your own servers. And that's it. That's the lightning tour of developer experience at Supabase. Hopefully you've got a good picture of not only what Supabase is, but how it works and how we think about providing that superior DX. There's obviously tons more of tools that we take inspiration from that I didn't get to cover in this talk, like Vercel and Netlify and all of their CLI experiences, for example, how they interact with GitHub, are all great examples of what we all should strive to achieve when we're developing developer tools. And this is a shout out that if you like what you see and you want to help us, obviously you can contribute as an open source contributor. Just go to our github.com/supabase/supabase. But if you want to really go all in, go head first into the world of Supabase, then we're hiring for tons and tons of roles. We're globally remote, so you can work on Supabase from anywhere. We don't care. We don't set working hours for this reason, because people basically are working around the clock in every different time zone, so you can choose to work whenever you want. And if you like building developer tools, I'm certain that you would like working at Supabase. We have a really talented team, and it's growing basically every other week. This is our tagline. We think you should be able to build in a weekend and scale to millions. Again, you can find us on GitHub. That's my email address. Twitter @Wilson, or Twitter @Supabase also. And head to supabase.com and start having a play around. Thank you very much.